launch right in.
I can say a sentence, but mostly just welcome everyone. My name is Jordan Ashwood. I'm the Partnerships Manager at Clinton Global Initiative University. Thank you all for being here today for this session on leading edge technology. I am thrilled to sort of pass the mic over to my colleague, Josh, who works at Verizon and will be leading us through this interactive session. So over to you, Josh.
Absolutely. Thank you, Jordan. Thank you to the CGIU team for putting all of this together. I really appreciate it, as always. Such a pleasure working with y'all. I'm Joshua Ness. I'm a senior manager with Verizon 5G Labs, and I promise this is the last time I'm going to read what's on the screen. We're here to have a conversation, have some fun. Let's talk about what 5G is, what these leading edge technologies are, and what Verizon is doing here with the Clinton Global Initiative. This is our second iteration, our second cohort of the Forward for Good Challenge, and we are very excited to work with you and to answer your questions and to see how we might build some new applications of technology that help people in a variety of areas. If you haven't had a chance already, please do visit the landing page, the website for the Forward for Good Challenge. There you can see the prompt areas where you can see the general categories where we're looking for innovative ideas. Jordan, if you want to go ahead and just put those prompts into the chat box for everyone, that'd be helpful. So we can make sure that we're keeping all of this in mind and in context as we start talking through what we're about to cover. Now, just to give you a little bit of additional context, my job at Verizon is to predict the future. And when I say that, I'm not joking. I'm not even being cheeky or funny about it. We know that 4G gave us a bunch of innovations, which we'll talk about here in a second, innovations that we hadn't actually planned on. And we know that 5G is going to do the same thing in a wide variety of areas, both for consumers, people like you and me, as well as for businesses in a variety of industries. And we'll talk about all of those. So what I'm going to share with you is some backstory about how we got to where we are, some pontification about where it is that I think we're going, and then some use cases or some areas where we've already applied a lot of these technologies to help people. I really want you to be able to use that for inspiration, and don't think just because we've already tackled a certain area that means that you need to stay away from it. We do want to hear any great ideas that you have. So when we're talking about 5G, also, if you have questions, feel free to put them in the chat. I do have the chat open. If you have any sort of comments on things that I say, some of the things I say might be fairly controversial, especially if you're an NBA fan. If you have anything to say, please do go ahead and put it in there, and I will just go ahead and respond to it here in real time. We all know what G means, right? The 5G. We all know exactly what that is, don't we? In case we don't, the G stands for generation. It is this is where we're coming up on the 5th generation of wireless technology, and each generation has brought with it successive capabilities that have led to new advancements and new applications of technology. 1G, that Zach Morris phone. If you know why it's called a Zach Morris phone, please do feel free to put that in the chat, just so I know that I'm not aging myself too terribly bad. With calling capabilities, right? The ability to make a voice call, pretty much it. 2G brought with the texting. 3G was over-the-air syncing of things like email and calendar, very low data-intensive applications. And then 4G is where we are right now. That has given us pretty much everything that we use to live our lives with our phones and with our devices now. Seriously, nobody knows why it's called a Zach Morris phone? Maybe by the end, maybe somebody can Google it.
It's by the bell.
So in the, feel free to type it in the chat. Howdy, did I get kicked off? Okay.
Oh, ever so briefly.
All right. How much of that did we hear?
I heard almost all of it until you just were talking about having people put Saved by the Bell. in the chat, or Cassie mentioning Saved by the Bell.
Way to give it away.
No, Cassie had put it into the chat.
I missed it. Thank you, Cassie. I appreciate it. So yeah, Saved by the Bell, one of the greatest TV shows that really taught us what it's like to be in high school, because it was so realistic, wasn't it? Love that show. In 2007, and I'm going to talk a little bit about why this marriage of hardware and connectivity is so important. So in 2007, Steve Jobs announced the iPhone. Right? He said it was a new touch interface iPod combined with a next level internet communications device and a whole new type of phone, all rolled into one. Right? And everyone lost their minds. Everyone went crazy. And 3 years later, when we were already on the second or third iteration of the iPhone, the most innovative application that we had was Words with Friends. Right? This was pretty much an application that took advantage of the connectivity capabilities of the time, which was 3G, because 4G wasn't released until 2010. And so once 4G came onto the market and became available for devices like the iPhone and other smartphones, then we started seeing this explosion of new types of capabilities, the ability to do pretty much anything that you can imagine on the go. Right? And so we're talking about all types of communication, whether it's video or audio or text, whether it's watching videos or listening to music, or looking at contextual applications that were updated in real time, like weather forecasting, or even things like working on Google Docs, or getting an Uber and ride sharing. It pretty much spawned the entire gig economy. Right? And so there are entire industries and people's livelihoods that have been built on the back of 4G. And a lot of people don't even really look at it that way. They look at 4G connectivity as something that we've always had. Well, we know that's not necessarily true, because if anyone in this room has ever owned a BlackBerry before, you know that pretty much all you could do is email and calendaring. Right? And so now we're up into this 5G world. And as you compare these three types of technologies that most of us have a memory of in our lifetimes, we have here a pretty good metric for like how fast 5G actually is. Right? It's the ability to download massive files in the blink of an eye, right? And so that's just one way to think about it. And new ways to think about it are going to be, how can we move real-time information back and forth? How can we analyze it with artificial intelligence and machine learning so that people like you and me can make decisions that can hopefully have a positive impact on people's lives? Now, the whole point of all of this is that it's going to drive this, what we call a fourth industrial revolution. There have been three of them before us, and each of them has come about because of big, giant leaps forward in technology. But none of this has ever happened in a vacuum, right? There's always been other types of supporting capabilities that have really helped to bring about this new way of doing things, these industrial revolutions, and this fourth industrial revolution is no exception. Connectivity is the thing that will drive this merger of the physical and the digital, right? And we'll talk a little bit more about what that's being called right now and how we see that really evolving. And so 5G, and as an example here, 5G is going to offer up these 8 additional benefits, or 8 currencies, as we call them, that are up far and away better than what we currently have with 4G connectivity. Everything from back-end things like energy efficiency and mobility, through to stuff that we actually know is going to impact us in the real world, with things like much lower latency, much higher reliability, much higher throughput. And so all of these are going to combine to give us new advances in technology. Now, the reason I put this up here is to start things off with a little bit of what is a cautionary tale, right? This is Star Trek from back in the day. This is Star Trek from the 1960s. It was one of my favorite shows growing up. And part of the reason is because they really put a lot of effort and thought into thinking about what will advancements in the future really be. And you can go ahead and Google, like, what are all the different types of technology that were depicted in Star Trek, which have now become a reality? Things like a communicator, right? Things like other types of medical devices that can, like an MRI machine, whereas not very small, like in Star Trek, they're coming down in things like size and cost, and going up in things like efficiency. We're able to do medical diagnostics and things like that, right? And so, but the cool thing I think about these two photos is they're holding the same device, which which at the time was their depiction of what a tablet might look like, right? A portable device that could either be used for communication or for data representation, data output. But what you notice there is that this futuristic tablet still has like these glass domed diodes on the top of it that are lighting up and giving information just through like the showing of light. Right. And so it was interesting for me, this particular device, because they were thinking about as far ahead as they could, using the type of framework that they already had at the time. And at the time, using things like diodes was almost revolutionary. And so for them, they didn't even comprehend like what comes after the diode. Right. And so as we're thinking about some of these technologies, I want you to just take yourself out of where we are right now. And a great example is this device right here. I don't know if you can see me in the little square, but the phone that we all have in our pockets or in our purses. Right. Sometimes you have two of them if you're lucky enough to have a work phone. I say lucky, a little tongue in cheek there. Is this device here to stay? I don't know. We'll find out here in a little bit. We'll talk about that. So like remove yourself from what you think is established right now and put yourself into a future forward state and think about how everything around you, even the things that you think are foundational, might advance, right? And so 5G itself comes in a couple of different forms. One of them is we can now beam high-speed connectivity into homes and businesses and other structures, right? We don't necessarily need to run new cable connections into businesses or new homes that are built. We don't need to upgrade things from copper coaxial cable into fiber optics, which is not scalable. It's very difficult to do. We can now beam high-speed internet into the window, and we can offer up very fast connectivity to infrastructure, right? And this is a really exciting thing that we're doing in places like shipbuilding yards in Virginia or glass manufacturing facilities in New York State. And we all, especially having lived through the pandemic, we all are pretty familiar with a scenario kind of like this, where everyone is on a device doing a different thing, and it brings the network speeds way, way down, right? And that was something that we've all had to deal with over the past year and a half. Well, something like 5G fixed wireless access, it solves that problem and it fixes it so that we can all be on our devices doing what we want, working with these data intensive applications without having a significant impact on the network capability, right? Now you extrapolate that to like, what else does that mean that we can do? Like, what are some other even higher data intensive applications that we can start working with, and how will that impact us as we're in these locations? And the other, of course, is 5G mobile, right? It's 5G to your phone or to your device, whatever that device is. And so we're starting to see a much higher percentage of people with 5G capable devices. And as we move forward, we're going to start to see new types of applications that can be used and taken advantage of by those devices. A really great example is the evolution of content creation and content consumption. And so whereas before, to make some of these older animated shows, which are pretty cool, it took massive data centers. It took lots of time. It was very difficult to move these high fidelity graphic images back and forth. And so there was just a lot of infrastructure that had to be in place. Well, now using things like 5G and edge computing, and we'll talk about that here in a second, we can begin to create these assets in real time. So instead of having to create them, render them, store them, render them again, transmit them, and ultimately use them in a production, now we can actually just do that all at once. Using things like what you see her here. She's in here as a motion capture suit. And then we can even take that one step further into something called volumetric capture, where she doesn't need to be wearing all those dots and all that stuff on her face. There can just be high definition, high fidelity cameras that can capture somebody and instantly turn them into a three-dimensional asset that can be used in things like virtual reality, augmented reality, or holograms, things like that. And this is an example of how they can be used given the devices that we have now. On your left, you have a full-size rendering, high-fidelity rendering of the greatest basketball player who ever lived, Michael Jordan. Don't even at me. You're not going to win. And then if you have these digital worlds that you can go into, well, almost like a portal that Dr. Strange would use to open up and then walk through, and then you can actually move about a physical space and see a geographically anchored digital world that is right there on top of where you are, almost like another dimension, right? And then add on to that the ability for these dynamic filters that can be used in all sorts of capacities, not just the traditional ones that you can think of now, things like masks or, like the puppy dog ears and things like that. Now advance this into more almost like a storytelling medium, and you can start having high fidelity, augmented reality images and narratives on a device, combining that with things like spatial audio. And now we start really pushing the boundaries of what we can do as far as narratives go. And if you're not catching everything that's on these slides, I'll make sure that y'all get a copy of these. And the ultimate, not the ultimate, but like the next evolution of that is real-time visual and audio devices, similar to like an Oculus VR headset right now, where you can be out and about in a park, realizing that, oh crap, it's Champions League week right now. I want to see how my team is doing. Putting on those glasses and immediately being transported onto the field with the help of things like high fidelity 360-degree cameras that might be worn by the players or that might be on the field, but being able to, in real time, be in the action of something like a soccer match or a concert or maybe even like a surgical procedure, right? And because it really just depends on what type of environment that you want to use this technology, because it's not just related to that. It can be in retail, it can be in healthcare, robotics, or education, and there's a wide variety of industries, and we're trying to explore pretty much all of them. Now, I mentioned this before, this thing called multi-access edge computing, or MEC, as you sometimes see it described. Now, it's really important to define what this is, because this is going to be one of the foundational technologies that takes advantage of 5G and delivers value in a bunch of different other areas. Now, the idea here is that you can take the cloud, which is compute, storage, and rendering capabilities that is located not where you are, but somewhere else, right? And so there are major cloud providers, groups like Google or Microsoft or Amazon with AWS. They have these cloud farms, these cloud servers that are located in various places around the country where information is stored and can be called, right? And so if you're on Instagram, if you're on TikTok and you're wanting to view a piece of content, that's not on your device. You know that. Your device is making a call out to the cloud to grab that file, which is located and stored in one or multiple servers, and bringing that back to your device. And we can do that in pretty near real time, right? There's a little bit of buffer, a little bit of lag. With things like Instagram and TikTok, we're okay with that. A little bit of buffering on a Netflix video on your phone, we're okay with that. If we're driving a car at an autonomous vehicle at 90 miles an hour and it needs to change lanes, we're okay with a little bit of lag, right? Probably not that last one. No, that people could probably get hurt. So we need information to be transmitted, sent out and back in real time, because as we move forward with new types of data-intensive applications, not just Instagram and TikTok, but autonomous vehicles or remote robotic surgery, we need things to be happening as fast as humanly possible. Edge computing is a big part of that. It basically says that we can take the cloud, those cloud resources, and we can bring them closer to the end user so that information has to travel much less distance and can be computed very, very quickly, sometimes faster than if it were computed on the device itself. And that has really big implications for the nature of devices. Things like phones can begin to change into something different, because all of that capability that the phone has to have inside of it can now be outsourced using 5G into edge computers, right? And so now that opens up this whole idea of what a device can be if the data doesn't have to follow a path all the way out to that centralized cloud. If it can remain in the network, then the device itself has to do less work and the device can begin to change. And so we know that this can be used for things like creating some of that next generation content. I mentioned being able, this is an example of that volumetric capture stage that I talked about before. It's using 5G and edge computing to take what is inside that little ring in that green room and turn that into a 3D asset almost instantly, which can then be used in production. It can be used for fan engagement and things like that. Now we're starting to use some of these capabilities in real world scenarios. And I mentioned retail as one of our focus areas. I know there's a lot of content here. I'm not going to spend a ton of time on it, but like I said, I will make sure that you get a copy of this slide. And so we're talking about being able to use things like computer vision and 5G and edge computing for monitoring the placement of objects in a retail location to make sure that something isn't on the wrong shelf or something isn't sold out, right? We can also use this for monitoring where people are in our retail facilities, figuring out what are they picking up and playing with? What are they engaging with, right? Is that in the right place? Is there something that whenever anyone walks by it, they always pick it up and look at it because it's really cool? Is that in the best place for traffic? Is it in a high traffic area where the highest number of people can actually engage with that particular product and then potentially make a purchase decision, right? And so this is all using computer vision combined with artificial intelligence sent across 5G to an edge computer and then to a dashboard so that employees of those retail locations can make better decisions about how their stores are laid out. Another is things like non-fungible tokens. We all have heard some of the buzz around NFTs. It's the idea that you can assign a token to a pre-existing three-dimensional asset, whether that's or a two-dimensional asset. Things like a video of LeBron dunking, or a graphical image of a painting or something. But what about like a three-dimensional object? What about something that is a 3D object that can be used in things like virtual and augmented reality and holograms, where that object can be instantly created using that process we talked about before, volumetric capture, can then be instantly tokenized and sometimes even combined with other tokenized assets to create something new. Now, this also this has huge implications for things like fan engagement, and it can lower that barrier to entry so that folks can begin, or other communities can begin to use these technologies, right? And this takes advantage of 5G and edge computing as well. And we actually demonstrated this in an event with the esports team Dignitas. We did this several months ago, where fans, and you can see there, like in that center GIF, the woman in the bottom right, Sam, she's a fan who just received a merged token of two separate tokenized assets, and it's that player in the top right. She essentially signed a 3D version of herself, which can be interacted with on the right. You can see that she can actually put that, the fan can actually use that 3D image, that token that she purchased, that NFT that she purchased, and can then engage with it and put that out into social media. Now, I mentioned before about phones and about how phones can begin to change based on the new types of technologies that are available to them. And we're already beginning to see that in the form factor. And we can see that right here, Samsung has started rolling out new types of devices that move in new types of ways. And as 5G and edge computing become even more ubiquitous, we're going to start to see those form factors changing even more, right? Now, this is Google Glass from several years ago. It didn't really take off, and it's not hard to see why. Right, because you got this individual here who's wearing these weird set of glasses. Is he filming me? I don't know. What else can you even do with those glasses? And it really didn't take off because the functionality wasn't there. And a big part of that was that the device itself wasn't powerful enough to do much more than look kind of weird, right? And so now we're moving forward into an age where Snap is partnering with Ray-Ban. This is essentially like these two devices are essentially the same object. This is allowing someone to record video to then post it to their social media, whether that's Snap or what have you. But the form factor is much, much better. It takes advantage of better types of connectivity. And as we move forward into a 5G world, now we're going to start seeing what does augmented reality actually look like in an eyepiece, right? And so this demo was from a company called North. They had such a revolutionary product that they were immediately acquired by Google, who has rolled them into their ambient computing division. And if you're not familiar with ambient computing, it's very similar to spatial computing, but it's the idea that you can use other parts of your body, whether that's your eye movement or your head movement, in combination with your hands, to be able to manipulate information and have that shown to you in different ways. So spatial computing and ambient computing are two types of technology that are about to grow immensely with the help of 5G and edge computing, so that we may be able to have a scenario like this where just with our glasses, we're able to be on a video call. We're able to be immediately taking measurements of objects in front of us so that we can perform a wide variety of tasks with just pieces of eyewear that probably also have some sound and some speech, some natural language processing embedded inside of them. And if you do have if your vision for this is similar to mine, then we're starting to see this spatial, personal, virtual ecosystem, right? Now, Mark Zuckerberg and the folks at Facebook are starting to dub this the metaverse, how we can begin to interact with each other both physically and virtually, right? And we're already starting to see the beginning of that. So much so that Facebook just announced they're thinking about a name change to better reflect their vision for what this metaverse is going to look like, right? And so we're already starting to see that in environments like AltSpace. If you have an Oculus headset or a type of VR headset, and you've been in an environment like AltSpace, you know that it has some very, it can almost feel like the real world. The way that we interact with each other, the spaces where we interact with each other, coming up to a group of people and starting to talk to them is very much like doing the same thing in the real world. If anyone's ever been to like a networking event with your classes or things, you know that it can be interesting to have to walk up to a group of people and begin talking to them. And in VR, they've really been able to replicate that real world feel of engaging with people. And now you start having, what does that mean when we start putting that into the real world applications of things like business meetings and other types of environments where we want people to be able to engage with each other, both physically and digitally, right? And so they have, there's several visions for what this is going to look like. Now, we've been able to extrapolate some of these into social impact areas, and that's what I want to talk about here. So my team at 5G Labs in New York City, we ran a program several years ago that was this educational technology challenge, this EdTech challenge. And this is one of our winning teams that was able to use 5G and edge relationships to create VR and AR data visualization and collaboration tools that explored language through hip hop and the geography of hip hop and what sort of language was used around the world in hip hop lyrics that would help students learn more about how language transcends geography, right? How it moves around the world. Another was visceral science, the idea that that multiple students could be in a virtual reality environment and undergo complex tasks like creating a galaxy or creating a star, and working together collaboratively on new types of projects. And this is something where this gets back to this metaverse idea of let's bring people together who might not be located in the same place, and let's work on something. Let's do something productive in a virtual environment, right? And so this is another one of those one of the winners of that EdTech challenge. And we've done the same thing in healthcare. Verizon has a platform called Blue Jeans, where we're able to provide video conferencing and telemedicine solutions so that patients don't necessarily need to leave their homes. Now you start combining that with new types of advanced computing, and we might reach a point where a patient's device in their home, combined with the Blue Jeans platform and 5G and edge computing, is able to do things like diagnose whether that's skin conditions or eye conditions or anything physical that can be picked up by a camera, might be able to be processed using artificial intelligence and allowing the doctor to make better decisions. Here's a great example of that. This is a company called Avacia that we've partnered with, using 5G and edge computing combined with artificial intelligence to help a doctor identify potential cancer areas on a routine exam. And the idea being that if we can catch these early enough, then treatment options are much more flexible, and the patient's rate of recovery is drastically increased, right? And so this essentially gives doctors an extra set of eyes where they can identify these problems early and help drive better patient outcomes. Another here is using augmented reality to overlay the results of CAT scans or MRIs onto an actual patient during surgery, and being able to see these things, and for the doctor to be able to be wearing eyewear and being able to manipulate some of this in real time, so that they can make better decisions when the patient is on the operating table. And so this is a company called MetaViz that we've also worked with using 5G and edge computing to be able to make this a reality for doctors. Another example of how we're applying some of this is through our Forward for Good accelerator. So you're part of this Forward for Good challenge as students or recent graduates. We also have something for established startups. And we just wrapped up a climate justice accelerator where we selected 7 startups that were innovating in that space. We enrolled them in a program and we gave them access to mentorship and advisory in all areas of their business, including technical. And so we were able to work with a company called Fireball, which does early wildfire detection, taking advantage of 5G edge computing combined with artificial intelligence and machine learning to be able to identify potential, no pun intended, hotspots in a forest region and be able to address those early before they get out of control. Another is this company called CareWeather. They were also part of the Forward for Good accelerator. Their vision is to, and what they've already demonstrated, is to launch these small satellites that up into the low Earth orbit that can measure wind speed over the ocean and be a better predictor of adverse weather instances, and they can help at-risk communities better prepare for what's going to be coming their way. Both of these companies received and continue to receive support both from business and technical perspectives, so that they can get their businesses up and running and impact more people faster, right? And so to bring it all together, we're getting to the end here, and I'm happy to answer some questions. We're talking about leveraging combinations of technologies that use connectivity, advanced connectivities like 5G, to drive better outcomes for people who stand to improve their economic and social opportunities, people who have different types of needs. Because, and I mentioned this before in the last slide about the Forward for Good accelerator, we're now focusing technologies on disability innovation. And so how can we use 5G and related technologies for things like enhanced navigation? This is a company called Wayfinder that we've worked with. They use beacons inside public places like train stations or subway stations or arenas or things like that, so that people can get enhanced navigation and help them people who might have other types of disabilities. And so with 5G, that might even eliminate the need for those beacons, and we might be able to provide those services to somebody on the fly wherever they are. Another here is an organization that came out of Columbia University called Pally that uses 5G to assist people with cognitive and behavioral disabilities in changing the way that they interact with the world around them and changing the way they interact with people. So it measures their responses to certain prompts and then gives them visual representation of how well that response is likely to be received by the people around them. And they've demonstrated how this can help people with behavioral disabilities be able to better interact with communities. And so all of this gets into the question now of, can we create a new type of internet completely? And this goes back to my conversation about the Star Trek example, right? Does the internet need to be something that we tap with our finger? Does it need to be something we use a mouse to navigate? Can we create new types of information inputs and outputs that people of varying types of abilities are able to access and take advantage of, right? Can we create an internet that you can feel? And how do we start bringing all of these different types of inputs, visual, tactile, audio, speech? How do we start bringing these together to create ecosystems of devices so that people of any type of ability can get what they need to live better lives? I'm going to close this out by going into the industrial side. We know that robotics is a huge area that's going to be growing like crazy, whether it's in factories or whether it's delivering your food or whether it is autonomous vehicles or drones. We know that 5G, we've already demonstrated demonstrated this, combined with new types of input mechanisms like virtual reality and augmented reality, can improve factory operations, whether that's reconfiguration or controlling things like drones or forklifts and things like that, or allowing these devices to operate autonomously, making their own decisions on the fly based on information they get from the world around them. And the same is true for things like manufacturing, logistics, supply chain. 5G can be used with some of these other supporting technologies to make sure, to address situations that we see right now with this supply chain shortage. How can we make sure that make sure that products are moved around most efficiently and they get to the people who need them the most? And so as you're thinking about your solutions and your ideas, be sure that you're taking into account things like human rights, and think about the holistic impact of your ideas. It might help a certain group of people, but is that at the expense of others, right? And what sort of features and what sort of capabilities can your idea have to minimize or prevent adverse impacts, and to help help as many people as possible? And so I want you to really think about how the communities that you are seeking to impact, who do they communicate with? Who communicates with them? Where do people where does value stand to be created, and where can it be taken away? And what are those, how are you weighing that as you submit your idea? So closing this out, one of the big reasons we do this is because we don't necessarily want to wait for the future to happen to us. We want to work with people like you who have really interesting ideas to build that future together. And so I'm personally very excited about this this new cohort this new iteration of the Forward for Good Challenge, and I can't wait to see some of the ideas that you have. So if you have any questions, I'd be happy to answer them here today.
Gareth, you can go ahead and ask your question. I saw that you raised your hand.
Yeah, thanks. A couple things. Firstly, LeBron James is the greatest basketball player of all time, and I just wanna let you know Michael Jordan's great, but LeBron James is like
we're done.
He's a little modern, you know. Secondly, so I was curious about like the technology itself. You mentioned the decreased latency because data is being stored in like a cloud, more or less. And I guess in order to incorporate that better into my idea, I was just wondering if you had any suggestions on like where to learn about how that works, or like I guess just to delve a little bit deeper into it.
Yeah, absolutely. I think if you go to the Forward for Good Challenge landing page, and you click into the prompt areas, I believe there are some links that you can click to dive deeper into some of those supporting technologies. Edge computing is one of them. But you're also able to, I can provide some resources, and the CGIU team can share them out. I have quite a few on edge computing specifically that will probably help you kind of help everyone kind of wrap their heads more around that as a concept. It really is taking the cloud and moving it physically closer to the end user, so that those individuals or organizations can experience, like I said, decreased latency, with the ability to move compute power away from the end device itself into the network, which can help with a wide variety of things. So yeah, happy to provide those resources, and please do feel free to follow up if you have any additional questions about that.
Yeah, well, I guess regarding that, like, is there, and I don't know if this is answered on the site, I'll be sure to check that out. Thank you for that. But is there like a limit to how much data is stored in that, like in the, I guess in this edge computing platform?
Well, we're talking about both storage, things like dynamic content caching, as well as compute. And when we're talking about edge compute, we're talking about the ability to process information, not necessarily store it, but process it. All of the things that your phone does, because like when you think about it, how many things are actually stored on your phone? The answer is not that many. Your photos are, unless you have them automatically uploaded into the cloud, and then you can then go and delete those from your device itself. And so what happens, what your phone is then used for is as a computational tool that actually processes information. And right now, for most people, it's usually just processing things, which are those feeds from things like social media networks and anything else that you might use, and other communication mediums like a WhatsApp or like a Signal or something. But as we start moving toward more computational heavy applications, both on the consumer side and the business side, a device like that you might hold in your hand, in order to make that robust enough to power those new applications, this would have to grow in size and bulk and all of that, and wouldn't be feasible to carry around either as an individual or think about things like robotics, having to move things around and reconfigure things. And so the idea there is you can take the computational capacity away from the end user device, move that into the edge. So it's less about storage and it's more about how do we crunch numbers and get information back to the individuals. We can embed artificial intelligence and machine learning in the edge so that it can analyze thousands and thousands of inputs and then deliver in real time contextual information so that people like you and me in the communities that you're trying to serve can make better decisions that impact their lives. So less about storage, although storage is a thing, more about the computation.
Gotcha, thank you.
My pleasure. I'm excited to hear your idea.
I'm excited to present it, honestly.
And actually, Garrison, if you want to share your idea now and get any like thoughts or feedback from Josh, I'm sure he'd be happy to. So no pressure if it's not fully fledged yet or anything you don't want to, but you're welcome to.
Gladly, definitely. First off, sorry if you hear cars going by. I'm actually outside attending the class where we talk a lot about these technologies that are revolutionizing business. And so my idea is to crowdfund solar projects in order to create a virtual power plant and use the profits from the virtual power plant to install solar in low-income communities. And so when it comes to 5G, I see this fitting in perfectly with everything that I'm doing, because virtual power plants, not only is it important to understand how much data is being pushed out, but also you want to know the price of energy on energy markets in order to know when to push out electricity from the storage capacity that's like linked to people's houses. And then on top of that, there's the actual pushing out of storage capacity. So making sure that we're not only in touch with the energy markets as well as the hardware that are on people's houses, but that we're able to connect with both, interpret that data, and instantly like push out that data onto the grid or the electricity onto the grid. So this is really, really like, I don't know, kind of gossip. Like I'm very interested in learning more about this.
That's really interesting. I'm excited to hear more about it. It almost sounds like taking some of the principles of high frequency trading and applying them to something that actually is beneficial for people. Things like the energy market, and keeping an eye on the market itself, so that you or whoever is operating this virtual power plant or who's benefiting from it can benefit from it at the most optimum level in real time. That actually sounds like a great idea. I'd love to. I can't wait to read that.
Exactly. Yeah, definitely. And I mean, on top of that, there's the potential of, I know you mentioned the Internet of Things. And so when it comes to demand response and electricity, one of the ways to take loads off of the grid is to like actually sort of reach into people's houses and like turn down the thermostat like 2 degrees, or just find ways to like shut off lights that they're not using and just make their home more energy efficient. So yeah, this is very much like right in line. I'm excited to share it with you.
Oh, I love it. No, that's great, Garrison. Thank you for sharing that. That's really interesting.
Yeah.
Are there any other questions from anyone else, or comments or project ideas you'd like to share, since we have Josh with us?
Well, Josh, I actually have another question. So will you all, I guess who's reading the applications themselves? Is it just CGIU, or it sounds like Verizon's also like directly reading the applications? Is that correct?
Yep, I'll let Jordan provide some additional context, but it's a group of people. It's a mix who are assessing each of the five categories in the rubric, which is also on that landing page. You can read all of the different areas where an idea will be evaluated, and those areas are being evaluated independently, and then will result in an average, and then we'll move forward based on those averages.
Okay.
Yeah.
And is there sorry.
Yeah, no, I was just going to add that's, yeah, great context, Josh. And there, yeah, you're close. There's 6 categories in the rubric, and I actually can put it in the chat right now, just the direct link to it. So definitely check it out. But as Josh said, it will be sort of a larger selection committee that includes folks from VentureWell, from Verizon, from CGIU, and not only from those organizations, but even just topic experts within those networks for those 3 organizations who, you know, would make sense to judge the 5 different content areas. And so there'll be sort of an initial review of those applications and submissions, and then there'll also be a selection of sort of semi-finalists who are invited to an interview round, and you'll be interviewed then by various members of the 3 organizations too.
Awesome. Okay, and I mean, I'll also be sure to look through those documents. As far as like when we do apply, I guess how much are we going to be greater on our understanding of the technology itself, and like how in depth should we go about how the technology interacts with like what we're trying to do?
I think, Josh, maybe you and I can tag team on this. Yeah. So for the rubric, the categories are weighted a little bit differently. So an understanding of the problem and technical feasibility, those are the 2 that are weighted a bit higher than the others. And really that's to make sure that, you know, we want to make sure that you have a firm understanding of the origins and scope of your problem before you start ideating and coming up with a solution for it. And then for the technical feasibility, you know, I'll let Josh really chime in here, but, you know, we accept applications at all stages of development, but we really just want to see that you've thought through a bit what that plan for the development of your technology could look like. But I'll pass to you, Josh, just for any other details there.
Yeah, on the feasibility, we're not necessarily looking for a deep understanding of the back-end architecture. But if you're talking about a community using virtual reality to solve a problem, on the technical feasibility, we're not necessarily looking at how likely is it for this community to have access to virtual reality. We're looking at, have you thought through how something like VR is going to interact with the data that you're trying to feed to it, where that's coming from, because if you're talking about something that's accessing public information or maybe new types of information or combinations of information, where are these types of information, where are these feeds being combined, where does the algorithm live that is doing that work, and if the answer is usually going to be in the cloud or in the edge or on the device itself, and so we're just looking for a general understanding of is this something that could actually work. And so using real world examples of how something similar is already working, and being able to dive into that. And there's a bunch of research that can be done on how existing technologies have been deployed. Referencing those, saying it would be similar to XYZ would probably go a long way into helping the technical feasibility judges wrap their heads around what it is you're trying to do.
Hi, I have a question. Clara, who's also on the call, and I are working on our project together, and we are in Maine. So we have a little bit different perspective, it sounds like, because in Maine, one of the big initiatives by the state right now is to increase broadband, and they're working diligently on making that happen. So we're kind of starting at a different point here with our social justice issues of incorporating businesses from rural Maine into getting more exposure. So do you have any suggestions on how we tackle that? Because really first we're working on supporting the initiatives of the state and a couple different initiatives of the state in their 10-year or 9-year strategic plan, which is to develop broadband, increase business exposure, more diversity and equity, all those things. And so we were working on all of those as part of our project. But I guess I'm just thinking our technology that we're thinking of is a little more basic, which is first to get it in the rural areas of the state and then to expand from there. So how do you suggest we incorporate in some of this advanced technology? Because we're starting from a pretty low point in a lot of the areas we're working on that need the social justice support.
Yeah, that's a great question. And I think that we're not necessarily looking for solutions that are only going to impact like dense urban areas that are going to have access to super fast 5G immediately. I think first and foremost, structure your idea to operate within the constraints of the community that you're trying to impact. And so I think you're totally on the right track of thinking through what are the resources that are available, maybe either right now or within 1 to 5 years, but then have a future forward vision for when connectivity and some of these remote technologies like cloud and edge computing are available. What does that next generation of your solution look like? And so I think that would go a long way in saying we've looked at what we can accomplish right now, and we know that we can build something that'll impact people right now based on the resources that are available or plan to be available. But then moving forward, we're not just stuck in this myopic vision of, oh, all we want is to be on par with New York City. What happens when these advancements do reach your community? How can they continue to take advantage of that in more meaningful ways?
Okay, that makes sense. Thank you.
Any other questions, thoughts? All right. Well, thank you all for attending and